Welcome to VTeach. In today's session, we will be discussing about the memory organization of 8051. In what way the internal memory and external memory are being organized. So here, the organization of the memory is being split into two ways, that is program memory and data memory separately. The program memory will always be considered as read-only type memory, whereas data memory is organized as read-write memory. So here if you see this, memory is being splitted in two ways, program memory and data memory. Even program memory is again classified as internal and external. Data memory is also been classified as internal and external. In program memory, the internal memory will be of 4 kilobytes, whereas external memory will be of 64 kilobytes. Whereas in data memory, the internal memory will be of 128 bytes, whereas external memory will be of 64 kilobytes. So we can simply say that we always rely on data memory rather than program memory. So when we talk about memories, we will be concentrating on data memory rather than program memory. So we can say that the internal memory of 8051 will be having 128 bytes and we will call it as RAM, and the external memory will be considering it as 4 kilobytes of ROM. So here the data memory of internal and program memory internal will be taken as a single unit. Got it? Data memory internal and program memory internal. Data memory internal is called as RAM, program memory internal is called to be as ROM, and it is always 64 bits. The address bus is of 8051 is 16 bits, where it will be able to access 2 power 16 locations. That means 64 kilobytes of the locations can be accessible, and we can able to configure the entire program memory outside the chip, or we can use 4 kilobytes inside and 64 kilobytes outside the chip. Means directly I will be able to use the entire memory locations that are being available. And always the internal data memory will be accessed by 8-bit address and the external data memory will be accessed by 16-bit addresses. And the maximum data memory that could be available in 80851 will be 64 kilobytes. Let us see the RAM structure in what way it is been there. So as we said that the RAM structure is of 128 bytes, and in which 0 to 7 we will call it as register bank 0, 8 to F we will call it as register bank 1, which can also be said to be as stack, and 10 to 17 we will call it as register bank 2, 18 to 1F we will call it as register bank 3, 20 to 20F we will call it as bit addressable memory, and 30 to 7F we will call it as scratch pad memory. So here the entire 128 bytes is been divided into 3 groups. So first group is of bank group, the second group is bit addressable group, and the third group is scratch pad. And here see, a total of 16 bytes from the locations 20 to 20 FH are kept aside for bit addressable read or write memory, and the rest of the 80 bytes are kept aside for usage as a scratch pad. And 32 bytes of RAM is divided into 4 banks of registers, in which each bank is going to contain 8 registers. See here, bank 0 you are going to have 8 registers, bank 1 you are going to have 8 registers, bank 2 and bank 3. Every bank is going to consist of 8 registers, and when 8051 is powered up, all the register banks are going to be initialized or resetted to 0, and switching the banks will be possible when we use program status word. In program status word is a register through which we will be able to switch from one bank to another bank. So D3 and D4 bit of program status 4 will decide which bank we are been using. If I am using D00, it is bank 0. If it is 01, it is bank 1. If it is 10, it is bank 2. If it is 11, we are using bank 3. The major problem in 8051 is register bank 1 and stack are using the same memory space. So, if in a given program, if we have to use bank 1 and bank 2, we have to reallocate another section of RAM to stack, that is locations higher than 60H. So, you have already seen bank 1 and stack are using same memory locations. So, in a program, if I require to use bank 1, then the stack space allocation should be given separately. So, here there is a stack operation that we need to consider. The stack is a section of RAM where we use to store the data temporarily, and here always the stack memory is being accessed by stack pointer. So, stack pointer is of 8-bit size. So, whenever the stack pointer or 8051 is initialized, the stack pointer will be addressing to the top of the address location of the stack. So, the initial value of the stack pointer will be 07, and the storing of CPU register will be done by push and pop instructions. So, when push is done to the stack pointer is incremented by 1, and if pop is done, the stack pointer is going to decrement. And stack follows always last in first out mechanism, and the stack pointer can be initialized to any internal RAM address by the programmer. So, by using special function register, I will be able to specify from which location the stack could be written. And here an example of push and pop instructions, in what way they are been using. Move R6 25, move R1 12, push 6, push 1 I had written. So, the stack pointer is pointing to 7 here as the starting address. So, this is the initial condition. So, when push instruction is been executed, the 25 value is been placed here. Then next, when another push is been executed, 12 is been placed. So, you are going to have 25 12, and when pop is been there, you are going to take out the first value. So, when pop instructions are being executed, you are going to take out the last in first round. So, here is a program status word which defines the bank register, and it will be able to check the status of the 8051. So, here in this 8-bit register only 6 bits are being used. There are 2 unused bits are there. They are considered to be as user definable flags, and out of 6, 4 are conditional flags. Those are carry, auxiliary carry, parity and overflow, and the other 2 are used to select the banks. So, already we had seen that what is that banks, that in what way they are being selected. So, carry flag, you already know that whenever carry is being generated, this carry flag is going to be set as 1. If not, it is been 0. And even this carry flag can be set by using some instructions such as set bit carry, in that way, or clear carry. So, these are the instructions. By instructions also you will be able to program this carry. Auxiliary carry is the carry that is going to be generated when we add or subtract the BCD data. Parity flag, you already know that parity flag reflects the number of ones in the accumulator. If a register contains odd number of ones, then we will be considering the parity as 1. If it is even, it is 0. And overflow flag, this has been used whenever we are been using signed number system. If the number is been too large, then we are going to have the effect of overflow flag. And this overflow flag is used to detect the errors in the signed arithmetic operations. and carry flag is used to detect in unsigned arithmetic operations. And as I said, we have been talking about special function registers all the time that are been there in the memory. So these are going to occupy 128 bytes of internal memory and control of the entire process, and they can be accessible directly. And the special function registers are here accumulators, which are A and B, processor status word or program status word, IO ports, data pointers, serial data buffers, stack pointer, timer registers, timer control registers, power and port control registers, interrupt control registers. All these 10 comes as special function registers. So register accumulator A is a register which performs addition, subtraction and logical operations. Accumulator B is used for multiplication and division instructions to be accessed by general purpose registers. So this is the special features or special function registers of 8051. Thank you.